Hello everyone, in this video we're going to talk about how we can dilate a shape. So this would not be a rigid motion like a translation, rotation, or reflection. This would be a similarity transformation, okay? So first of all, what is a dilation? It's a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. Most of the time, especially when you're doing this on a coordinate plane, the center of dilation will be the origin 0, 0. And we'll get into that when we get to the examples later on. Angles of the shapes are congruent. That's key there, right? So it's the same shape, but it's a different size, okay? So if it was a triangle, it still needs to be a triangle. If it was a quadrilateral, it still needs to be a quadrilateral, but we've just enlarged it or we've reduced it with respect to the center of dilation. So just a quick example or two examples here. Let's just tell if these shapes are dilation. So number one, obviously we got a little bit bigger there. We had an enlargement. So we're going to say yes, that would be a dilation. We changed size, okay, but it's still the same shape. Number two, though, our size did not change. So we're going to say no, that is not a dilation, right? Perhaps that was a rigid motion. Perhaps those shapes are not similar, but they are congruent, okay? So we'd say no there. All right, now we mentioned this earlier in the video. So now let's talk about dilations in the coordinate plane, okay? So the value of the ratio of the side lengths of the image to the corresponding side lengths of the original figure is the scale factor of the dilation. So a lot going on there in that definition. Let's break it down just a little bit. The value of the ratio of the side lengths of the image. So the image, that's talking about the new shape that we've created from the original shape that was given to us. Okay, so now how did we create that? We created it by this number here that is our scale factor. Okay, so scale factor is represented with the variable k. And what do we do with the scale factor? We multiply the coordinates of each vertice by that scale factor, and that'll give us the coordinates of the image or the new shape that we get from dilating the original shape. So we're going to multiply that, so we see that listed here. It's just k times the x coordinate, k times the y coordinate, and that would give us our new vertices. So now, depending on the value of k, we could either be making our original shape larger. If k is greater than 1, we would call that an enlargement. Or if k is between 0 and 1, not negative values here, that's going to be something else you'll talk about in geometry later on, but we're talking about a fraction between 0 and 1, so maybe 1/2, 1/3, 1/4, something like that. And if that is the value of k, then we would call that a reduction. So let's look at one example of each of those here, and we will dilate the shape. Okay, so now my color is black here. Let's shift that. Let's go with the blue color for number one. So we have our triangle here. It looks like we have E would be, that's hard to see. Let's go back to black for now because we're going to write something on the bottom. So E looks like we have 1, 1, right? I'm going to draw a little arrow there because we're going to be multiplying those values by our scale factor to get the vertice of our new shape. F is 3, 1. And D looks like 1, 4, okay? Now, I know I didn't write those in alphabetical order. Could have done that. It doesn't really matter because we're going to be graphing all three of those vertices to make our new shape. So let's do each of those. So it tells us that k is equal to 2, which means this is going to be an enlargement. So when we graph our new shape, we should expect it to be larger, right? Okay, so let's multiply here. So 1, 1, so we'll call this E prime. So that apostrophe symbol there, you pronounce that or you call that prime. That just means it's the new vertice after you've done your transformation. So we're multiplying by 2, so this would just be 2, 2. F prime would be 6, 2. And then D prime would be 2, 8. Okay, so now I'll go to my blue color and we can graph these vertices here and see how the shape enlarges. So E would be 2, 2. That's going to be right there. Excuse me, E prime. Okay. F prime is 6, 2, which would be there. And then D prime is 2, 8, which would be here. Okay. So now when we connect these vertices, the shape should still be the same. Okay. It's just gotten larger. All right. And so now one thing, when we dilate on a coordinate plane, the center of dilation will almost 100% of the time be the origin, right? And so since that's the case, we should be able to draw a line like this in which both of our points that we dilated, they are on these lines that go through the origin, right? So it would be something like that. Okay, now you don't have to draw those rays every single time. It's actually not part of doing the dilation, but it's just a way for us to check to make sure our points are along those rays that should be going through the origin, because that's the center of our dilation. Okay. All right, now let's look at a reduction here for number 2, and then we'll wrap up the video. So it says k is 1/2, so I know that's between 0 and 1, so this shape should be getting smaller. And let's write down our vertices. So we have A, we have B, we have C, and we have D. So A looks like is 6, 4, B is 6, 10, C is 12, 10, and D is 12, 4. So let's do the same thing. Let's draw an arrow here, and we're going to do A prime, B prime, C prime, and D prime. So now our reduction is, or our scale factor is 1/2, so we can just multiply these coordinates by 1/2. So half of 6 would be 3, half of 4 would be 2. Then B prime would be 3, 5. And C prime would be 6, 5. And D prime would be 6, 2. All right, so now let's shift our color. Let's go purple this time, and let's graph our image. So A prime is 3, 2, so that's going to be right there, A prime. B prime is 3, 5, so that's going to be right there. We'll call that B prime. C prime is 6, 5, so it's going to be right there, C prime. And then D prime is 6, 2, D prime. All right, so now let's draw our lines here, connect those. We're good. And last one, perfect. Okay, so now let's draw those rays again just to make sure our points line up. So let's go through A and A prime. Right there, very good. And then we got B and B prime. Very good. C and C prime. Right there. And then D and D prime. Right there. Very good. Okay. All right. So that's a little bit about dilations and how you can dilate a shape.